Howdy everybody, Bill Sky, the assembly guy here today. It's been a while since I've done a video because I've been concentrating on some other content on YouTube regarding computer technology. Take a look at it. COBOL is one of the things that I'm doing. I'm about to get started with Linux as well as Fortran. So these are topics that every developer should know. There's opportunities out there like crazy for those languages, so take a look at those. But back to what we're doing here today. What we're going to do today, long promised, is that we're going to do a video on how to create a random access file. By random access, I mean you don't have to start at the beginning and go to the end to read the last piece of data at the end. You can just jump to the end. You can jump to the middle. You can jump to the beginning. You can jump anywhere you want in the file. But before that, I would like to do a little drawing and show you what random file access is all about. Actually, what we're going to be doing today is what we call relative file access, but it is the beginning of being able to do random file access, which is the center of every database technology on the market today. So let's get going with the overview. All right, so let's take a look at what a random file is actually all about. What does it actually mean for there to be such a thing as a random file? Well, I've got my Linux up here, and you can do this with just about any operating system because the meaning of a random file is the same on all operating systems. So now if you haven't watched the fileIO videos before this one, please take a look at the description of this video and go back and watch those because it's very important for you to have that basis of knowledge to be able to move forward with this. Now, random file I/O is available on every operating system. It's available on every programming language just about. Actually, I think it is every one. And it's just, what does it mean? So I'm going to draw here. I'm going to draw what looks, oh, that's kind of fat. Let's do that over again. Okay. So I'm going to draw a simple box. And this box is basically a representation of a file on your hard disk, on your SSD, on your thumb drive, whatever. Now, the file has a beginning and the file has an end. And a lot of times they call the end of a file EOF, end of file. It means that there's no more file to be read. Or I mean, you can always write to the end if you're opened as output, but you can't read past the end. Now, where is all this information kept? All this information kept is in the file system's directory structure for the storage device. So I could probably teach an entire semester on file systems and directories. So let's go ahead and talk about what a random file is. So let's say, for instance, that I have written a bunch of integers to this file. So here's the integer 12. Here's the integer 14. Here's the integer 22, here's the integer 08, and here's the integer 11. Now there are 5 pieces of data out in that file, 5 integers. Each integer, let's say, is 4 bytes in size. So even though I'm only showing 2 digits, let's pretend that there's 2 zeros in front of each one of those. So this integer right here is 4 bytes. This one is 4 bytes. This one is 4 bytes, and so forth. Now my drawing isn't perfect here, but give me a break. Okay, so each one of those is 4 bytes. Now how do you normally read a file when you open it up, read it, and process the data? Well, you'll do it sequentially. So there's this idea of sequential access. And sequential access, it means that you start at the beginning and go to the end of the file. You just process all of the data in the file that way. That's sequential. And that's the way you've probably been doing it your entire life, your entire programming life. That's the way that tape drives do it today and always have, is because the tape actually is a physical tape device, and it must always start at the beginning and go to the end. So let me go ahead and erase this. So what random file access is that there's a number of steps that you do. Instead of starting at the beginning, on random, instead of starting at the beginning, you position the read pointer to the location in the file that you want to read. Let's say, for instance, that we want to read the third item in the file. We want to read this 22. Now, we don't know it's the number 22 necessarily, but we want to get to there. So you position the read pointer. Now, every file, when you open a file, it has a read pointer, and that read pointer points right there. Okay? So if you want to read that, item, you position the read pointer there, and that's what that green arrow is. It's basically the read pointer. And how do you do that? Well, you say, I want to get the third item. Each item is 4 bytes wide. The first item is at position 0 in the file. The second item is at position 5. The third item, or actually position 4. The third item is at position 8. So there's a little equation you do. You say position is equal to, I don't know, the entry number minus 1 times the size. So because the size is 4, we're going to say, so we want to get the third item in the file. We say 3 times 4 is 12. So we would, or I'm sorry, 3 minus 1, because we want to get to the third one, right? The third one minus 1 is 2. 2 times the size is 4. 2 times 4 is 8. And that takes us to our third position. So we move the read point to that position, and then you read the data. So the first one is to position the read pointer, the second one is to read the data. Now, part of positioning the read pointer also means to calculate where you're going to do that. Now, we're going to do this in code today, and you'll see exactly what I'm talking about. So you position the read pointer and you read the data. Now, in languages like COBOL, also some of the database languages out there that you can interface with your compiler, your program that you compile, it does all of this for you. You might have heard the term indexed files. If you haven't, I'll be doing a video on that in my COBOL series, also possibly in my C and C++ series. But all that's done for you underneath the covers because it's done down at assembler language, at the assembler language level. So that's another reason why assembler language is so important. So now once the read pointer is positioned at the number 22, and let me see if I can, in this case, the number 22, let's see if I can erase that. So once it's positioned there, what actually happens to the read pointer? Well, the read pointer then is positioned here to the next item. So then I could read the next item if I wanted, or what I could do instead of that is I could position it over to the second item. If I don't want it, when I'm done with that, I can then position it over to the last item. I can randomly position that read pointer anywhere I want and then read the data. So, okay, so if you didn't quite get that, jump back to the beginning of this description and rewatch it and maybe write some stuff down on a piece of paper to get, to better understand it. And then go back to the coding sections, which we're about to do. So let's actually implement this in some code. All right, so we went over what random files were. We actually did some drawing to show you exactly what it means. And here we are with the code. Now, if you jumped ahead to this coding part, you didn't look at the drawing that I did before this, you're really going to have a problem, I think, if you've never done random file access before, no matter what the language is. If you've never done it, you're going to have a lot of problem here. So jump back and take a look, because we're going to be talking about read pointers. We're going to be talking about positioning it, calculating it, and reading it. And again, this is the basis for just about any database system on the planet. So I've got Linux up here, but this will work just as well under Windows, no problem. Windows pretty much does things the same way, except you position things a little bit differently. And I'll maybe put those differences in the description of the video. So what I've done is I've created an assembler language program here. And this is the first time I've ever done this. I actually have code already in my program. So let's go through this and then fill in the blanks. Because the way that I'm going to do this, I didn't want to have to write all this code live with you because we've already done stuff like this in my previous videos. But let's go ahead and take a look and move forward then writing the actual code to access the random file. Okay, so I've got a whole bunch of strings described here or sitting here. I've got the open prompt which says welcome to my program, the close prompt that says program ending. And then we've got a bunch of things, we've got a bunch of strings to display errors. So I've got if the file was created incorrectly, or if it opened, it didn't open, or we had problems writing it or opening it. for input open. I just got a bunch of different messages there. And then we've got our file name string down here, and that's the file name that we're actually going to produce. So what this program is going to do, it's going to produce a file. It's going to put, I think, 100 quad words, 100 8-byte words into the file, or 8-byte numbers into the file, and then we're going to grab them randomly. Okay, so we've got our output file handle. Again, this is the variable that contains the location of the file. We've got our input file handle, which we will be using when we read the file randomly. We've got a read buffer. I believe that was for, yeah, the read buffer is what was for something in a previous project. I don't even know if it's required here. Total read, and int value is really the one that we're going to be reading. So int value is where we're going to be reading the data from the file and putting it into this quad word that I've reserved here in the BSS section. Okay, so let's quickly go through this code. So I go ahead and I print the open prompt. I print a prompt that says I'm writing the data to the file. And then I go ahead and I create the file. So I move 85 to RIX. I move the file name string address to RDI. I set up the security attributes. I go ahead and I then do a syscall, which will create the file. Now, if the file already exists, it's going to overwrite it. That's okay for what we're doing here. I make sure that RIX contains something other than 0, because if it does contain 0, that means that it did not create the file correctly, and we had an error, so we had to display it on the screen. If it did work, we go ahead and I move that to the open output file handle. I move that number, that value in RAX that we'll use to write to the file. Okay, the second thing we want to do is we want to write a bunch of quad words to the file, each 8 bytes in size. So I just create a little loop here, and in the loop I started RAX with 1111H hex, and then in RCX I put 100 because that's going to be our loop counter. We're going to write 100 numbers to this file. And I go ahead and I move the value into the int value register. I move 1 into RAX, which means I want to write the file. I move the output file handle from the open into RDI. I move the actual address of the integer that I want to write, 1111H, to RSI register. And then I say I want to write 8 bytes because a quad word is 8 bytes. And I push RCX because RCX is actually modified by the syscall. When you write something to a file, RCX is actually overwritten, so you need to save RCX because RCX is used to manage this loop. Because if you don't know what the loop verb is, I suggest you go and take a look at my loop video for assembler language, but RCX is the loop counter. Okay, then I make sure that RAX, after it's called, after I write the data, I make sure that RAX contains 8 because that means that's the number of bytes that were actually written to the file. If it's not equal to 8, then we had an error. So we jump to that and that displays an error message. Otherwise, I go ahead and I move that integer value back into RAX because RAX was overwritten with the number of bytes that we wrote with the syscall. And I go ahead and add 1111 to RAX again. Now it should be 2222. I pop RCX because RCX was pushed up here. I pop it to recover it so the right loop goes on. So that loop right there will go ahead and write 100 quad words, 100 8-byte words. Now it's interesting, as I'm talking, I was noticing these comments over here. You know, it's been close to a month since I've done an assembler language video, and these comments told me exactly what I was doing. I didn't even have to look at the code to remember what I was doing. That's why it's so important to put comments in your code. All right, so then we go ahead and we close the file, and then I display a message saying we're about to read the data. Okay, so now once the file has been closed, it's been created, the data's been written to it, and it's been closed, we open the file for input. Now before we do that, I want to go ahead and I believe I haven't run this yet. So let me go ahead and run this. Let me build it. Okay, it looks like already built. Let me go ahead and run this. And if you notice, there's a new file, intfile.bin. That's what that code did. It actually created a file called intfile.bin, and it's got some data in it. Now I'm going to open this up with ghex, And it probably would have been faster for me to do it with the command line, but what the heck. Okay, so here you go. So you can see our numbers. That's 4, 5, 6, 7, 8. Now it's in little endian order, so it's backwards, right? Because that's how little endian order is. And I wonder if we can change this. Let's go longwards. There, yep, it's still little endian order. So the number that it saved was 00001111. Now, if you don't know what little endian order is, I suggest you look back on my other assembly language video on little endian order. I did a specific one on that. So you can see our first number, 111. You can see 222, 2, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5. So that's what's in that file. Now remember, each one of these numbers is 8 bytes, so we can now calculate where the 66660000 is. We can calculate that. It is the 6th one in that file. So if you remember from my overview of random files, you take the position you want to get to, in this case the 6th position. Is it the 6th position? Yes, it is the 6th position, because this entire thing here is the single quad word. So it's the 6th position. So we're going to take 6 minus 1 is 5. 5 times 8, what is 5 times 8? 40. So this 6666 begins at position 40. So that would be 8, 16, 24, 32. This would go from 33 to 40, and our 6th item is at location 40. 40 bytes from the beginning of the file. So I showed you that to show you that the data really is there. Okay, so now what we're going to do is back to the code. We're going to open the input file, or we're going to open the file for input. So we go ahead, that's an RAX of 2. The file name address is put into RDI. We move 0 into RSI, which means we want to open it for input, and then we do the syscall. After that, we want to make sure that RAX is not equal to 0. If it is equal to 0, that means it didn't open correctly. So if it wasn't equal to 0, or if it is equal to 0, we go ahead and jump to a part of the program that prints an error message. And then we go ahead and we move RAX to the input file handle. All right, so here we go. Here we're going to start writing some code now. So what we're going to do first is that we're going to ask the user to please input a value. Now you might have seen that when I ran this a little while ago, and I can do it again. Whoops. It's asking me to type in a record that I want to read. Do I want to read in the 50th one, the first one, the second, the 90th? Which one do I want to read? Now notice that the prompt also says -999 to quit. So if I put -999, the program just ends. If I put the number -10, the program gives me an error. It says, oh, you put in a negative number, you've got to put in a non-negative number, so it goes back up. So anyway, so if I want to leave the program, just 999. Okay, so that's basically what this loop is doing right here. Okay, so I go ahead and I ask the user to type in a number. Now this is using the Linux input signed integer function in my Komanetsky libraries for assembly language. I never wrote one of those for Windows. I really need to get around to that, but in Linux it works great, and I'm probably going to move it over to Windows relatively soon. Now the jump carry means that there was an error. The user typed something incorrect. They typed in the letter ABC instead of the number 1, 2. So if the carry flag was set, it jumps to input error and a display is shown, or an error message is shown. If they type in -999, we want to leave the loop. We want to leave the loop and finish the whole thing, as you might have seen when I demonstrated it. Now we want to check to see if they typed in something negative. If they typed something negative other than -999, well, you can't go backwards in a file. You can't go before the beginning, so a negative number doesn't make any sense. So we display an error message if they do that. Okay, so here we go. So now we're going to write some code. And again, I did all this simply because we need to get all of this infrastructure in place before we actually write this code. Okay, so let's see. Let's go back. I'm jumping around. Okay, so notice I've got comments here, and these comments are so important. Really, what I should have done is this. I have to put all these to-dos, just another hint on how you can keep track of what you've got left to do in your program. So we've got a number of things to do. So what we need to do is we need to calculate the position to read the file. Now, if you remember, it is the item number -1. This is the calculation times the size of each item. So if they type in the number 6, which is what I showed you in the demonstration using GHAC, so they type the number 6, you subtract 1 from it, that's 5. 5 times 8, which is the size, is 40, and then we move the position pointer. Okay, so let's go ahead and do that. So what I'm going to do is I'm going to move into RBX 8. Now, why am I putting 8 in there? This is the size of a quad word. This is the size of each item in the file, each number in the file. Now, this program right here, this function right here, input signed int, it puts into RAX, the result of typing in a number, the user typing in a number, RAX contains the position, the number that the user typed in. So we're simply going to move 8 into RBX, and then we're going to do a multiply RAX with RBX, and you simply do that. So you say multiply that into RAX. So RAX now contains the position from the beginning of the file where we can find that 6th in that description or that example I was using, where we can find that 6th number in the file. All right, so that's done, so we don't have to do that. Now, I'm going to save this and build it to make sure I haven't typed in something. Okay, so everything looks good. All right. So the next thing we have to do is we have to position the read pointer. Now, if you remember in my drawing, there's literally a read pointer. There's a pointer that you can position within the file before you actually do the read. And it keeps track of where you are. It's kind of like a bookmark in the book that you're reading that's taking you 2 years to read. Oh, I'm reading the Oppenheimer book right now, and it's taking forever to read it. So thank goodness for bookmarks. Okay, so let's go ahead and position the read pointer. Now the way that we do that is we move into RSI the value RAX. This is the position in the file to start reading. Okay, so we move that. Now we're going to move into RAX 8. That is the function. Oh, I said 9. Let's change that to 8. That is the function. 8 means position the read pointer. Now we're going to move into RDI, the input file handle. Oh, input file handle. That's the file we want to read from. Assuming that it opened okay. And then we're going to move into RDX 0, which means from the beginning. And if you remember in my previous video, 0 equals from the beginning, 1 equals from the end. I believe it's from the end, right? Let me look at my notes. I believe it is from the end, yes. Or no, current. It's from the current position of the read pointer. And 2 is equal to from the end. And I put all of those comments in my code just so I don't have to memorize it. All right, then we do a syscall. So that's not reading it. All that's doing is positioning the pointer, the read pointer. So let's go ahead and build that. All right, good. So that to do is done. Now, we haven't tested it yet, but that's okay. We really can't. I mean, I guess we could debug it to make sure that it does it, but that's pretty involved. Okay, so the next thing we need to do is we need to read the quad from the file. So to read, and you probably have already seen this if you've seen my other videos, I'm going to move to RAX 0. That's read from the file. I'm going to move into RDI, the input file handle. Now you might wonder why I keep having to put that in there, because when you do the syscall, it might actually modify those registers, so I have to put those values. File to read from. Okay, then we're going to move into RSI, the address of the memory location where we're going to store the data, and that's the int value variable, where to read the data into. And then we're going to move into RDX 8. Oh, I keep typing 9. 8. The number of bytes to read. And then we do a syscall. And that's the tickle the kernel thing you might have seen in some of my other demonstrations. Okay, so let's go ahead and make this. All right, good. It made no errors. Okay, so now we have to check, let's get rid of that to do. And now we have to check, are we at the end of the file? So the way that you check to see if you're at the end of the file, now what does that mean? It means that I tried to move my read pointer past the end of the file. So there's 100 items in the file. I can type 0 to 99. And I'm not subtracting 1 here. I'm allowing the user to type 0 to 99. If I wanted to have them type 1 to 100, then I would need to subtract 1 from the number that they did. In fact, let's do that. Let's go ahead. So we're going to calculate the number. Let's see. So the number is an RAX right here. What we're going to do is we're going to subtract RAX1. The user types 1 to 100. Subtract 1 first. So that does this part of the equation. And then we go ahead and we multiply it. All right, awesome. All right, so that reads the quad value. Now, are we at the end of the file? If we tried to move or if we try to read past the end of the file, RAX is going to contain 0. So what we're going to do is we're going to compare after the read. So I'm going to say compare RAX with 0. Check to see if 0 bytes were read. We're going to jump if equal to, and I believe I have a function or I have a label out there called not found. And actually, no, I was wrong. No, I wasn't. I was correct. So if I try to read past the end of the file, like if I typed the number 200 to position 200, but we only have 100 items in the file, then RX is going to contain a 0 because you can't read past the end of the file. Okay, so that to do is over. And then we go ahead and print the number and we jump back to the top. Okay, let's see if this works. Okay, so let's test the error conditions first. So I'm going to put in -100. All right, that's great. Now I'm going to put in a very large number. I know I don't have 300 numbers in the file, so I'm going to put 300. And it says the position you specified does not exist in the file. That's the error message that I printed if the result of the read was 0. So that's what I did there. Now let's go ahead and put 0. Now notice there's no guidance here. So let's see if I put in 0, we say the position you specified does not exist in the file, because remember I'm subtracting 1 from 0, so it's a -1, so it's going to try to read from the beginning. It's not going to let me. So let's put a 1. Oh, there's my 111H. Let's put a 2, 3, 4, 5. Let's go back to 1. Let's go to 20. Let's go to 9. Let's go to 10. So we are now randomly reading the file. We started at the beginning with 1. We jumped to the 50th one. We then jumped to the 90th one. We then jumped to the second one. So we're moving that read pointer all over the place, and we're displaying the data as we find it. So I'm going to put -999 to quit the program. So that's random file I/O. Now, real quick, all of my little jumps? My little jumps just say they're like if it was not found, we say not found message. We print the error message, then we jump back up to the top of the loop. If it was an input error, we push that and we jump back up to the top of the loop. If we weren't able to open the file correctly, we print that error. We jump to end it all, which closes the program off and ends the program. So that is random file input. It's not random file output. I might do that later on in another video, but for right now, that's how you randomly read a file. So if you have a database that has thousands or millions of pieces of data in it, how does it find that data so quickly? It does it randomly. I mean, if you think about before we had disk drives, when we had tape, if you wanted to get to the very last item on a tape, you had to read the entire tape stream, or you had to position it to the very end of the tape, which you might as well read the darn thing. But in hard drives, in direct access storage devices like hard drives, SSDs, you can actually have that read pointer move it to the end and read the data very quickly. Whoa, that was so cool. I love coding random file I/O, and I hope to see you in our next assembly video.